Okay, everyone. Before I start the lecture, do you guys have any questions from previous lecture or lectures? Everything seems good? Okay. If no question, I'm going to start the lecture. So again, as always, I have the periodic table here listed to emphasize the difference between transition metals, nonmetals, alkali, alkaline earth, halogens, noble gases. So at this point, I hope you all are comfortable with the periodic table. So if I ask you in the exam, which of the following is not, I'm going to write this, is not a transition metal, and I tell you Fe, Ru, R, N, and Ru, Rh. What is the answer? Rn, right? Radon is a noble gas. So be comfortable with the periodic table and practice it if you need to. And these elements here, these are your transition metals. Okay, the rest are your main group elements, and we denote them with 1A, 2A, 3A, 4A, 5A, and so on and so forth. In the table that I give you in the exam, I don't distinguish A's and B's. So you should be able to identify that by studying prior to the exam. And also here, again, you have like nonmetals, metals, metalloids. We repeated those several times, so I hope now you are comfortable with those. Any question? Okay, so I have these three things that I listed in our previous class, again, to emphasize. If you know these three things, you can, in theory, solve all the questions in this, most of the questions in this chapter. So first one is molar mass, which has a unit of gram per moles. So how can I find molar mass of a specific element? Yes? Exactly. So elements atomic mass. And how can I find that? Anyone?
On the periodic table.
Exactly. We look at the periodic table and the number below each element. For instance, for carbon, this is 12.01, right? So that would be your atomic mass, which has a unit of atomic mass unit, or your molar mass, which in that case has the unit of gram per moles. That means 1 mole of carbon has the mass of 12.01 grams. Okay? Or it means that carbon atom has the average mass of 12.01. And that is atomic mass unit. Just looks at one atom, or if the atom, like carbon, has different isotopes, it would be the average of that. Do you remember how to calculate atomic mass unit for each element? For different isotopes? We had different abundances, right? And then you have the ratio. If you have like 20% of a certain isotope, you write 20 over 100 multiplied by its mass plus 80% multiplied with the mass. So that is atomic mass. So remember that atomic mass is the same numerically as molar mass, but the molar mass has the unit of gram per moles. The other thing is that if I give you, and I'm going to give you C6H12O6 in the exam, and I tell you in 1 mole of glucose, which has the formula of C6H12O6, in 1 mole of glucose, how many moles of hydrogen do we have? 12 hydrogen atoms, exactly, right? Or if I tell you in 10 moles of glucose, how many moles of carbon do we have? If I ask in 10 moles. Exactly. So you multiply 10 by 6, right? Okay, so know that. And finally, knowing 1 mole of anything has 6.022 multiplied by 10 to the power of 23 of that thing. And remember, you have also a 0 here. And I also tricked your SI pass leaders, here with this statement that you had in your quiz. Is the following statement true or false? If I say 1 mole of pennies has like 6.22, that sentence would be wrong, right? Remember that you have also 0 here. So you should remember this number. And you use these conversion factors to solve problems. Okay, the other thing that I want to finish this chapter, and at first I wanted to just solve problems this session, but I realized for the lab schedule, I need to progress the lecture so I can kind of catch up with the labs, that most of you have the lab. So for that matter, I'm going to continue the lecture, but I try to solve as many questions as possible. So I briefly said that the only time that we convert gram to grams directly is when I give you mass percent composition, which is basically if I want to calculate mass percent of element X in a compound, it would be mass of X in a sample of the compound divided by mass of the sample of the compound, multiplied by 100%, right? Just kind of like taking the percentage. If I say how many students got A in exam 1, you count how many got A divided by total number of students, right? If I want to calculate the percentage, multiply by 100%. So this is basically the same thing. And I have an example here, which I just took from your book to be faster instead of like solving the problem. Have it here. So the problem says, or the example rather, the FDA recommends that adults consume less than 2.4 grams of sodium per day. What is the chemical symbol or atomic symbol of sodium? Na, right? How many grams of sodium chloride, and what is the chemical formula for sodium chloride? Exactly. Can you consume and still be within the FDA guidelines? And it says sodium chloride is 39% sodium by mass. Is that clear what the question asks? And that is why this chapter is really important. Sodium chloride is table salt, right? We have restrictions for the amount of sodium that we should consume. And in order to know how much sodium we should consume, we should calculate the amount of salt, right? And here, when we say, or when your book says sodium chloride is 39% sodium by mass, what does that mean?
100 grams, there's 39 grams of sodium.
Exactly. If you have 100 grams of NaCl, 39 grams of that would be sodium. So this sentence means, if you have 100 grams of your salt, your ionic compound, 39 grams would be Na, right? So how many grams would be, out of 100 grams, would be chlorine or chloride, Cl minus? Exactly, 100 minus 39, right? Which would be 61, right? Grams Cl. Okay, so this is, as I told you, this is the only instance that you just convert grams of Na to grams of NaCl directly. And you can just write one conversion factor. In the denominator, you have grams of Na that cancels out, and then you find grams of NaCl. So these type of questions are really straightforward, right? You just write a ratio, and as long as you write it correctly, right, like here, remember that you write it somehow that the denominator cancels with the numerator, right? And then you solve this type of problems. Any questions so far? Okay. Now, the other formula that I talked about last session, and this is most of the questions that you see. Most of the times, we don't have the mass percent composition, but we always have the chemical formula, right? So from the chemical formula, we can find mass percent composition, okay? And you have two ways to deal with these type of problems. One of them is just like use the formula. The other is to write conversion factors as much as needed, and both gives you the same answer. And we're gonna solve an example for you guys to see that if you want to calculate mass percent of element X in your compound, you calculate you write mass of that element in 1 mole of compound divided by mass of 1 mole of compound, multiplied by 100%. Does this formula make sense to everyone? Good. For instance, if you want to calculate mass percent composition of Cl, chlorine atom, in CCl2F2, you remember that you have 2 chlorine atoms in 1 mole of this compound, right? That's why you put 2 here, because this would be mass of this element in 1 mole of the compound. So we write molar mass of Cl, and we remember that we have 2 chlorine atoms, right? Or like 2 moles in 1 mole of your compound. So this is the tricky part of this equation, or like this formula, rather. Because most students forget to write this number here, but other than that, you write the molar mass of your element divided by molar mass of your compound. And molar mass of the compound would be numerically your formula mass. So you say molar mass of CCl2F2 equals, you have how many carbon atoms? Right, multiply by C, plus how many chlorine? Plus how many fluorine? Right? And you go to the periodic table, you read these numbers. Can anyone tell me what is that for carbon?
12.011.
Exactly. What is it for chlorine? Exactly. What is it for fluorine? Can anyone read that? 18.998, right? And you don't have to, some periodic tables, the numbers are slightly different, like second or third decimal place. So I give you the table, so you don't have to worry about that. And then answers would be the same, whichever number you put. And this is how you calculate the molar mass of your compound. Any questions? Is that clear? Okay, now again, I have an example from your book, which is basically really similar to what I had in the previous slide. Calculate the mass percent of Cl in ferrion 114. So basically C2Cl4F2. And in case you're wondering, if you have like some compounds that you don't know how to name, I give you the chemical formula. So you don't have to worry about it. But for ionic compounds and molecular compounds that we studied how to name them, I expect you to know how to name them. So let me know if you have any questions. So now you want to find mass percent of Cl. So if we want to use the formula that we were given in the previous slide, you write mass percent of Cl equals, and you want to calculate that for Cl, right? How many Cl's, how many moles of Cl I have in 1 mole of C2Cl4F2? How many moles of Cl atom do I have in 1 mole of this? 4, right? What is, and then I write molar mass of Cl, right? And then in the denominator, I write molar mass of my compound, which is C2Cl4F2. Can anyone tell me what is molar mass of Cl? Anyone? Exactly. I remember it has like the unit of grams per mole. And can anyone help me to write molar mass of C2Cl4F2? How many carbon?
2.
How many Cl?
4.
How many F? And then for carbon, we have 12.01. For Cl, we have 35.45. What is it for F? Right? And then you just put this number in your calculator. But remember, if you're putting this number directly to in calculator, you should put parentheses for your denominator. If you put the number in calculator, right, like this, divided by 12.01 multiplied by 2 plus 35, if you don't use parentheses, your calculator first does this and then divide that by this, because first we should take care of division and multiplication, then addition, subtraction, remember? So if you put this number in calculator, remember to have another parenthesis for your denominator, because this gives you the wrong answer. Does that make sense what I'm saying? When you have mathematical operations, first you take care of, parentheses, then it would be power, okay? Then it would be multiplication. I guess I write, okay, don't confuse this with subtraction. 1, 2, 3. Multiplication, or division. And finally, you do addition, subtraction. Okay? So I don't want you to lose points because you just put the number wrong in calculator. That would be such a, loss. Okay? Any questions? So next slide. You should multiply that by 100% to get the percentage. Okay. Here, it's just what I just told you. Here, your book wrote the formula, and I forgot in the previous. So, have the answer here. I guess nicer version, more neat. And then something that. Yeah, if you don't do that, you get the number as 0.6958. So if I ask you for percentage, you should remember that it's 69.58%. So we multiply by 100% to get the percentage. Is that clear? Any questions? Okay. So I told you that if I give you like C6H12O6, this formula gives you relationship between moles of constituent elements of this compound, right? And we learned that we can calculate or convert moles to grams by molar mass, right? So technically, if I give you this formula and I tell you that I have like 10 grams of glucose, and how many grams of oxygen do I have in it, right? So just by looking at the chemical formula, you can relate or convert the mass of the compound to mass of the elements, right? And you can get information from the chemical formula, information about the grams and moles of the constituent elements. So now if I tell you, okay, I have this many grams of oxygen, this many grams of hydrogen, this many grams of carbon. Okay? And I tell you that I don't know the chemical formula of this compound. I just know it has carbon, hydrogen, oxygen. And then I give you the grams of constituent elements. Do you think I can calculate or find the chemical formula of the compound? Right? So we can find mass percent composition, right, from chemical formula. Now the question is that can we do the reverse? And the answer is yes. We can find empirical formula from if we have mass percent composition, which is basically having grams of the constituent elements, right? Can anyone tell me what was empirical formula? Is C6H12O6, is this empirical formula? No. Why not?
It's not the most reduced.
Exactly. So it should be the simplest ratio between these numbers. And as your friend said, it should be like the simplest version. So what is the, so this is, we call this molecular formula. So what is empirical formula of this compound? Exactly, we divide everything by 6. And remember that you shouldn't have any ratios or any decimal points. We don't write the chemical formula as like CH.5. Well, how should I write this? I don't want to have decimal. Can anyone tell me? Exactly. We multiply this by 2 because if I multiply 2 by 0.5, it would be 1, right? We want to have whole numbers. So empirical formula is the simplest whole number ratio between the atoms of a compound. Does that make sense? Questions? So this is yes, and we can find empirical formula with having mass percent composition. Okay? If no question, I'm going to, demonstrate how to solve or how to find empirical formula from mass percent composition by showing you an example. And this is from your book, example 6.10. It says you decompose a compound containing nitrogen and oxygen in the laboratory and produce 24.5 grams of nitrogen and 70 grams of oxygen. Calculate the empirical formula for the compound. So in these questions, what you do is that if you want to find empirical formula, you should have relationship between moles of constituent elements. Remember? We don't deal with grams. We always talk in mole because if I want to find the formula of the compound that has nitrogen and oxygen, it's moles, if it's like NO2 or like NO3 or NO, these numbers are moles. Remember, 1 mole of your compound has 1 mole of this, 2 moles of 1 mole of nitrogen, 2 moles of oxygen, and so on and so forth, right? So we need to find moles. So to find empirical formula, what you do is that you convert grams to moles. Okay? Is that clear why we do that? And what you do is that you say how many moles, the thing that you want to find, you write with question mark, right? How many moles of nitrogen equals 24.5 grams of nitrogen? Okay? And what should I write in denominator?
14.007 grams per mole.
Exactly. So I write, what did you say? Sorry.
It's 14.
Exactly, yes. Just making sure, yes. So gram, you write the gram in the denominator, and then you write moles in numerator, right? Because this is what you want to find. And as your friend mentioned, you go to periodic table, and then you find nitrogen, and I think I look here, it's closer to me, is 14.01, right? So 1 mole of nitrogen, this is like gram per moles. It means that 1 mole of that has this much of mass. Is that clear to everyone? Good. And you do the same for oxygen. Equals 70 grams of oxygen, multiply that by grams of oxygen in denominator, and then moles of oxygen in numerator. And what is mass of 1 mole of oxygen? 16, right? Or 15.999. Whichever you put, you get the same answer. So this also gives you moles of oxygen. Is that clear so far? And after you do the math to save time, I already copied and pasted your textbook here. So you have, when you do the math, you have 1.75 moles of nitrogen and 4.38 moles of oxygen. So you write N 1.75, oxygen O 4.38. Okay? Are we good so far? In the next, yes?
Why can we now use decimals but before for you here
So now still we're in the process of solving the problem. So we won't let that to stay decimal. Yeah, great question. Any other questions? Okay. After we do that, we write the formula like this so we can think it through and then see what to do. In the next step, we divide these numbers by the smallest number between the atoms. So if you have like 3 atoms and then you have like 3 different numbers, you choose the smallest one and divide everything by that. Okay? And then you put the number in calculator and then find the answer. So when you do that, let me kind of zoom here. Okay, when you do that, you get N1O 2.5, right? Based on just your experience working with numbers, can anyone tell me how can I get rid of 2.5 and make it a whole number? So if the number is really close to a whole number, for instance, if it's 2.999, yes, you can round it. But here, you have like compounds, for instance, I'm just writing it as an example, N2, O5, for instance, right? And then this compound is, if I divide everything by 2, it would be like N O2.5. So if I round this number, I get another compound. Does that make sense? So the ratio you round in the case that is really, really close to a whole number. But this number, 2.5, it's not, we don't round that. So this is like the short answer.
Multiply by 4.
Exactly. If you multiply this by 4, right, you get N4. And what is 4 multiplied by 2.5? 10, exactly. So if we want to find empirical formula, you should remember that this should be the simplest ratio possible. So what is the simplest ratio possible?
N2O5.
Exactly. So as your friend did, sometimes it's easier for us working with tens. So 25 and 4, we know that, it's just like more tangible. So you're welcome to do this, or you can just multiply this by 2 from the beginning and write N2O5. So both of them gives you the right answer. Just remember, when you're dealing with empirical formula, you should have the smallest whole number ratio between atoms. So if you write it like this, remember to simplify it. Any questions so far? Are we good with this? Okay. You're going to see this in your exam, so if you have questions, just tell me so I can explain further. And here your book listed this table here. So if you have like, so for instance here, we had like, if you have like these fraction or subscripts, you multiply the numbers by these numbers here, or like you multiply that, fraction by these numbers to get whole numbers, right? And for instance, if you have like, 0.25, you can multiply that by 4, or like 0.33 multiplied by 3. So I give you this table in the exam too. So in case you have like difficulty with math, that doesn't prevent us to answer the question. So, but you should solve examples to know when to use this table. Does that make sense? Any questions? Okay, if no question, I'm going to cover the last part of the chapter. So we can find empirical formula from mass percent composition, right? Or from like grams of constituent elements. But do you remember molecular formula? What is molecular formula? What's that? So empirical formula gives you the smallest whole number ratio between atoms, right? For instance, CH2O. But this compound in nature, it can be C3H6O3, right? Or it can be C6H12O6, right? Or it can be C2H4O2. So molecular formula gives you the actual number of atoms in a compound. But empirical formula gives you the simplest ratio. Does that make sense? Any questions? Okay. So if you have empirical formula, right, here, and we want to find molecular formula, we should find what number I should multiply this empirical formula by, right? So should I, if I have CH2O and I want to find whether I have C3H6O3 or C6H12O6 or like C2H4O2 and so on and so forth. So how do you think I can get from here to here? What's that? Exactly, but how do we get that 6? Right? So that 6 in this specific example is like this n here, right? How can I find that?
By the molar mass, by the empirical formula.
Exactly. So in the questions, your book, me, or whoever asked you the question, we give you the molar mass of your actual compound, right? And from the empirical formula that you find by the method that I taught you, you can find molar mass of your empirical formula, right? So if you divide those numbers, you can find that n. Does that make sense? Any questions? Okay. And remember this formula, that this N here is like molar mass, and you can write the molar mass of molecular formula divided by molar mass of empirical formula gives you N. And then when you multiply that N, for instance, as your friend said in one example 6, if you multiply that by CH2O, you find C6H12O6. Any questions? Is that clear? Yes?
Just to clarify, so you're taking C6H12O6 and dividing it by CH2O to get 6?
Yes, so what I do, and I can solve an example real quick to clarify that. So in your exam, you can find, let me just go to chapter 6. So you can find the empirical formula with the method that I just, taught you, right? And I give you the molar mass of your molecular formula. And then I tell you what is the molecular formula of this compound. Let me just write an example here. Okay. For instance, okay. I tell you, I have a compound with empirical formula of C5H4, and that is naphthalene. Okay, and then I tell you molar, this compound, this is empirical formula of naphthalene. Okay, and naphthalene is used in like mothballs that we use at house when we have moths. Anyway, and then I tell you that molar mass of naphthalene, and I forgot an H here. Naphthalene. Molar mass of naphthalene is 128.16 gram per moles. What is naphthalene's molecular formula? Okay. So what you do is that you have the empirical formula, right? So you say molar mass of empirical formula, which is C5H4, you calculate that. And how do you calculate that? You look at your periodic table, read these numbers, right? And then you say, how many carbons do I have? Exactly. How many hydrogens do I have? Right? And then substitute the numbers. And after you do that, you get, 64.09 grams per mole. Okay? And now to find the N, do you remember the formula? Yes, so molar mass of your, exactly, molecular formula divided by molar mass of empirical formula. Okay? So this number I just calculated is 64.09 gram per mole. And the other one, this one I just calculated, empirical, is 64.09 grams per mole. And molar mass of the molecular formula is given to you, 128.16 grams per mole. And when you do the math, this number, when you round it, it would be 2. Okay? And what you do is that you have C5H4, you multiply that by 2, and then you get C10H8. So it's just like the problem is basically finding molar mass of empirical formula that you know how to do, and then molar mass of the compound I give you, so just divide the numbers, and then you get a whole number ratio. So most of the time the questions that I give you, you can just round. So it would be 1.999, so you don't have to worry about multiplying. But if there is something that needs more calculations or like is tricky, I give you that table that I just showed you, so you don't have to worry about that. As long as you know the chemistry part, you will be able to answer the question. Okay? Any questions so far? So I'm going to post some sample quiz and exams from last semester, so you have several materials for your exam. And also, I'm going to just show them here as well. And last semester, students had to give me their solutions for quizzes. So this semester, you just answer them online. And before I forget, I will be available during the weekend, and I schedule Zoom meetings with you if needed. So just feel free, to reach out to me. And I'm the best resource for you. So, anytime you have any questions, I'm going to continue with the lecture, so don't leave. And I have attendance today, so. But I just wanted, I tend to forget things because I'm just rushing to finish what I'm going to talk about, and I forget to say things, and I'd rather to talk about these things in the class rather than just sending the announcement. So anytime you have any issue with any homeworks or like anything, just reach out to me, and I have like Zoom meetings with you, and I use the same thing here, same media, and then share my screen with you, so it would be pretty effective. And you have like several versions of homeworks that I posted on Canvas. Make sure to read and study all of them and know the answers, because chances are you see the exact same questions on exam and you feel pretty bad if you could have easily gotten an A and then you get a D or C because you didn't study those questions. So do that, So now I'm going to talk about this quiz as fast as I can and see how much we can progress. I want you to have like as much as resources, and I'm going to upload these on Canvas under the folder of, like, I create a folder of previous exams, sample questions, so you have all the resources. Okay, so I give you the periodic table and polyatomic ions, okay, in the exam. But and if I ask you a numerical question that needs conversion, I give you the table that I just showed you in today's session too. But chances are you don't see that. I give you the question straightforward, so you can answer the question just by rounding the number. Like the answer would be 1.999 or like 2.999, so on and so forth. Okay, but you should know how to use these resources to answer the question. So if I tell you what is the correct chemical formula, and I just want to hide the correct answer. Okay, so if I ask you to write lithium phosphate, how would you solve the problem? So what is lithium? So lithium is Li, but if it's in an ionic compound, what charge would that have? What's that? Positive, exactly, positive one, right? And do you guys remember what was phosphate? And I give you the table of polyatomic ions. So you look at the table, you should be able to identify phosphate, right? It would be PO4 3. And what you do here is, when I don't write 1, is like when I don't write anything, it's just 1. So one way is that to put this 1 here, this 3 here, right? So the compound would be Li3PO4. Does this make sense to everyone? And the same thing, for instance, for aluminum oxide. What is aluminum cation? 3+, right? What is oxide? 2-. Remember, you have, and then you switch these two, it would be Al2O3. But before me continuing with this, let me tell you, group 1A metals, lithium, sodium, potassium, rubidium, cesium, they have charge of +1, and they are in group 1A, okay? Group 2A, beryllium, magnesium, calcium, strontium, barium, they have charge of +2, they're cations, okay? And you should know that. Aluminum has charge of, is in group 3A, has charge of 3+. Zinc is in group 2B and has charge of 2+. Silver, Ag, is in group 1B, has charge of 1+. Okay, these ones you should remember. And they only have one type of charge, so we don't use parentheses, right? And sorry, your friend that is waiting for attendance outside distracted me. So remember that these ones you should know, and I don't give you the table corresponding to this, okay? The other part is that for anions, okay, nitrogen has charge of 3- and is nitride. Okay, don't confuse that with anything else, nitrite, nitrate, so on. So it's nitride. Okay, oxygen gains 2 electrons, would be oxide. Okay, this is sulfide. And then fluoride, chloride, bromide, iodide. You should also know these for your exam. Okay? Any questions? So I'm going to post the lecture along with several resources for you. And let me go back to the lecture today that I had and go to the last slide. Okay. So feel free to reach out to me, and I advise you to go through all the questions, and chances are you see the exact same questions from the resources that I post, and also your previous homeworks and exams. So I highly encourage you to study all of the things that I post. I give you the table of polyatomic ions. That here, I give you this. Yeah, I give you that. Don't worry.